All right, so we're going to talk about taking the second derivative implicitly. So we've talked about the difference between explicit and implicit form. That was 7.1. But now we're going to talk about how to do the second derivative implicitly, and it's a little bit different. Important to notice that this is the implicit definition or the implicit notation for the second derivative. And the 2, notice the 2 is in between the d and the y, but for the denominator it's actually dx squared. The 2's on the outside. You could think of this as the derivative of x squared. So let's talk about this. Let's just think about how we would do this normally, right? If I was to take the derivative, first I would just be like, oh, this is y prime, that would be 3x squared. Boom, done. And then if I want to take the derivative again for the second time, I'd just do the power rule again. It would be 6x, and we're done, okay? Seems straightforward enough because this is an explicit function. But let's do it implicitly just so we could see the process. Here we go. I'm going to take the derivative implicitly. The derivative of y is dy. Derivative of x cubed is 3x squared dx. I then divide both sides by dx, and now I have the first derivative. It's the same thing I had before. But now I'm going to take the second derivative, and what I do here to mark that it's the second derivative, I say d2y over still just dx equals 6x dx again, and I can divide by dx. And dividing by dx is the same thing as multiplying 1 over dx. So I get d2y over dx squared equals 6x. And now I've taken the second derivative implicitly. Now, obviously for this type of function, this would not be the most efficient way to do it. But on the next couple pages, you're going to see where we would have to do this implicitly. We're going to have to take some of those second derivatives implicitly. So let's go ahead and go to the next page. All right, so here they already gave us the first derivative, and we're trying to find the second derivative. So let's just go ahead and go for it. I'm going to go ahead and start off with my notation is d2y over dx equals, derivative of 2x is 2 dx minus derivative of y is dy. Okay, I know this looks a little bit tricky here because we got a dy and a dx, but the next step is the same. We're still just going to divide everything by dx, and you'll see what happens. And remember, that's the same thing as multiplying 1 over dx. So on the right, we're going to get d2y over dx squared. And then obviously dx over dx, this kind of cancels each other out. It's just 1, so 1 times 2 is 2. And then here I have minus dy over dx. That seems tricky, but look. Don't I already know what dy over dx is? It's 2x minus y. So I'm going to say minus, and then I can just substitute this in. 2x minus y. Okay. You could distribute the negative or whatever, but the point is we found the second derivative implicitly. Okay, let's go to part B here. This is a really tricky problem. There's a lot going on, so I want you to kind of pay attention. Expect to take up quite a bit of space on this one. So I'm going to zoom way in so I can have a lot of space to write. So it's x squared plus y squared equals 25. Let's start by taking the derivative implicitly. So that would be 2x dx plus 2y dy equals 0. At this point in time, you want to get the dy on one side and the dx on the other, so this would be 2y dy equals negative 2x dx, and then you're just going to divide both sides by dx, and you're going to divide both sides by 2y. So this cancels and this cancels. And so you have dy over dx equals, and the 2's cancel out, so you just have negative x over y. Okay, well, that's just the first derivative, though. We want the second derivative. And so if we're going to do the second derivative implicitly, that's all fine and good. We can do that, but notice now we have a quotient, and we have to use the quotient rule. So let's go ahead and do that. I'll do the second derivative in blue so we can tell the difference. So I'm going to say d2y over dx equals Now, quotient rule, derivative of the top is -1 times derivative of x is dx times the bottom, which is y, minus the top times the derivative of the bottom, which is dy, all over y squared. Okay. Now, to simplify this, it may be easier for you to think of this as 1 over y squared multiplied by. So let me just rewrite this in a way that maybe makes a little bit more sense for you. And that's a double negative, so that turns into plus x dy. So remember, I need to divide dx on both sides. I guess I'll go ahead and copy this down. So rather than just divide dx on both sides, well, this is multiplying, right? So I could just divide this whole thing by dx and then multiply this side by 1 over dx. And so I would get d2y over dx squared equals 1 over y squared times, well, here the dx over dx, I would just cancel out. That just becomes negative y. And here, that becomes x times dy dx. So okay, again though, I'm going to take this and substitute it in for dy dx. So still got some work to do here. So let's start simplifying. It's 1 over y squared, negative y plus, and remember, dy dx was really negative x over y, so I'm just going to multiply this by x times negative x over y. All right, it's getting a little interesting. 1 over y squared times negative y plus negative x squared over y. I could distribute in this 1 over y squared. If I multiply that through, I get negative y over y squared plus negative x squared over y cubed. And lastly, I could multiply by y over y to get common denominators, and I'd finally have negative y squared minus x squared all over y cubed. Wow. And that again is the second derivative of y over dx squared. Okay, so fun problem, right? A little bit of interesting algebra there, but very doable. Just got to find the first derivative, take the second derivative using the quotient rule, and then plug in that first derivative when it's called for in the second. Okay, let's go to the next page. Okay, it says find the derivative, but I meant to put a second there. Find the second derivative of each function. So let's go ahead and do this. We're going to do this all implicitly. So we're going to find the first derivative first, obviously. The derivative of y squared is 2y dy equals derivative of 4x is just 4 dx. And we're going to divide both sides by dx, giving me dy over dx, and divide both sides by 2y, giving me 4 over 2y. Okay. A couple different ways we can think about this. First of all, we can reduce this. So this is just 2 over y. And if it's 2 over y, then it's the same thing as 2 times y to the negative 1. And it might be a little bit easier to think about it that way when we go to take the derivative now, because we're going to do the second derivative. We'll do the second derivative in blue. So the second derivative is d2y over dx equals the derivative of 2y negative 1 is going to be negative 2y to the negative 2 dy. Okay, at first it may seem kind of confusing because you may be thinking like, okay, what do I do with this dy? But if you remember, we were dividing both sides by dx once we got to this point, or multiplying by 1 over dx. And so what we would get here is we'd get the second derivative of y over dx squared, which is our notation for the second derivative, equals negative 2. Let's go ahead and put the y on the bottom now. Let's be y squared. And then we have this dy dx. But we know what dy dx is. It's this. And remember, that 2 times y to the negative 1, that's really just like saying 2 over y. So instead of dy dx here, I can put in 2 over y. And I can simplify this now. I get negative 4 on top over y cubed. And so now I have found the second derivative. Pretty cool. All right, part B is going to involve the quotient rule here. And so I want you guys to try this one on your own. This is kind of the last one here. Give it a shot. We've already found the first derivative though, so you don't have to worry about the first derivative. You just got to worry about the second. So I want you to use the quotient rule, find the derivative of the derivative, so the second derivative, implicitly, and try and simplify it as much as possible so you have just common denominators. Give it a shot, and then check back when you're ready to check your work. Alright, so if you do the derivative implicitly, you're going to get 6x dx, 2y, because we're doing the quotient rule, minus the top times the derivative of the bottom all over the bottom squared, okay? So, let's clean this up a little bit. One of the first things I see is I got this dx and this dy. Remember, we're going to multiply both sides by 1 over dx, which is the same thing as dividing both sides by dx. And so let's clean up what we got. We get d2y over dx squared equals, well, when I distribute this 1 over dx in, these things just cancel out. So this would be 6 times 2 is 12xy. And then when I multiply these things together, I'm going to get 6x squared, so minus 6x squared. But I still have a dy over a dx here that I have to account for. Well, here is my dy over dx. So instead of dy dx, I'm going to put in 3x squared over 2y. And then remember that all of this is over 4y squared. Okay. So maybe another way of thinking about this is instead of having it all over 4y squared is we could use some parentheses. And we can make this like multiplying by 1 over 4y squared. It might just make it a little bit easier to think of. So let's just start cleaning up from the inside out. So I have to first, looks like I got to distribute here, or multiply there. And so I'd have 12xy minus 6 times 3 is 18. X squared times x squared is x to the 4th. And all of that is over 2y. And that's all being multiplied by 1 over 4y squared. And so I could actually do a couple things here. One of the first things I notice is I could reduce this, right? So this could just be a 9 over 1y. And let's go ahead and distribute that 1 over 4y squared in. So what would I get? I'd have a 12xy over 4y squared minus 9x to the 4th. And since I'm multiplying a y by 4y squared, that just becomes 4y cubed. Alright, the last thing I see that I can do here is I could get common denominators like I talked about. And so I'm just going to multiply the top and bottom of this by y. And so I would have, everything would be over 4y cubed. And I'd have 12 x y squared now minus 9x to the 4th. And there's the second derivative after using the quotient rule and simplifying it all down to getting common denominators. Yeah, pretty fun stuff. I just want to point out though, the only time I ever actually even did calculus was this very first step when I did the quotient rule. The rest of this was all algebra. So, got to be familiar with your rules of multiplying and dividing fractions. It really makes a lot of sense when you can just, instead of dividing by a term, you can multiply by 1 over that term. To know that those are equivalent functions is huge. It's going to help you a lot. Alright, see you guys in the next video.